Chapter 4, Exercise 25. Hints. For part B, prove that fractional parts of number n alpha, n is an integer, are dense in 0, 1 inclusive. Solution. A. On the space Rk, we use the Euclidean metric here. We will prove that the set k plus c is closed by showing that the complement, k plus c complement, is open. Let Z not element k plus c. Define this. The set F is closed since F is the inverse image of a closed set C under the continuous mapping here. Sets F and K are disjoint. Indeed, if X element F intersection K, then this for some Y in C. It follows that this, which is impossible. Exercise 21 implies that there exists delta greater than 0 such that this, if U and K, V and F. We will prove that this. Since X and K, Y and C, since X minus Y in F, we deduce this and that. The set K plus C is closed. B. Let alpha be an irrational number. Let C1 equals Z be the set of all integers, and C alpha equals Z alpha be the set of all numbers n alpha, n element of Z. Both sets C1, C alpha are closed as absolute value x minus y greater than or equal to 1 for all distinct xy in C1, absolute value u minus v greater than or equal to absolute value alpha greater than 0 for all distinct u, v in C alpha. We will prove that the sum C1 plus C alpha is a dense subset of R by showing that every non-empty interval, AB, exclusive, contains a point m plus n alpha, m n element of integer. Pick an integer k greater than 1 over b minus a and consider a sequence of fractional parts. Here, exercise 16. All numbers, fractional parts j alpha, are distinct. Indeed, if 0 less than or equal to j less than L less than or equal to k and this, then that must be rational, which is not the case. The segment 0, 1 inclusive is the union of k segments here. It follows that for some distinct JL element 0, 1 and so on to k, points fractional part j alpha less than fractional part L alpha fall into the same segment here. In particular, this. Let S be the smallest integer bigger than this. We note that the following. It remains to note that this. The sum C1 plus C alpha is countable as both sets C1, C alpha are countable and dense. In particular, C1 and C alpha is not closed. Comments. An essential part of the presented solution is the Dirichlet's box principle. If k plus 1 distinct numbers are distributed among k sets, then at least one of the sets contains at least two of these numbers. Assume that alpha is rational, alpha equals p over q, where p element of integer and q element of natural do not have common factors. If alpha equals 0, we take q equals 1. Then each number from the set C1 plus C alpha is of the form here. Conversely, since the greatest common divisor of p and q equals 1, Euclidean algorithm implies that aq plus bp equals 1 for some integers ab. It follows that for any integer L, we have this. So, the sum C1 plus C alpha equals the closed countable set here. We can view C1 plus C alpha as the image of the function here. This exercise shows that if alpha is an irrational number, then the function f alpha has a dense range. Thanks for watching.